Niko is working for Silo AI. I think you're the head of technology, which sounds very fancy, and certainly Silo AI is also a partner of FCAI, and I must say that I'm very impressed with Silo AI. You have a very broad spectrum of things to work on and work with, but I'm sure you will give us a good overview on those things there in your talk. Please.
Yeah, thanks Arno, and hi to everyone. Since there's quite a bit of people listening in as well, so happy to see that. But hopefully you'll also get a lot out of all these different presentations today. So quickly getting started. Supposedly we're not quite as big as Saab, at least not this year yet, in terms as a company. So it might not be that much familiar to everyone yet. So just in terms of a brief introduction, where are we coming from as a company? So we're a bit of a 3 years, so something like 3.5 years old as a company, focused on building AI-driven solutions, providing AI service to our clients. And already at this point, we are the largest private AI lab in the Nordics, and the key focus next is naturally to repeat that trick all across Europe. So as a starting point there, so we've now during the last year expanded to Sweden as well, and that's going to be the starting point. And there's going to be more continuation with additional countries across Europe as well going forward. So right now at this point, the company has something around 120 plus employees, and as you might see from the figures here, we are really a lot driven by latest and deepest AI expertise, and for that reason, more than half of our employees do hold PhDs. Well, not everyone probably in machine learning directly, but also in some related fields. For example, mine is rather from data mining originally, and then turning more to machine learning later on during my career. Then looking at why do customers actually choose us along the way? And these are probably a bit also in relation to what I'm going to talk about soon, about these specific practices and pitfalls in taking AI into production. But we've really seen that our key expertise is in defining long-term partnerships with customers and bringing the AI in more like a holistic sense as part of what they want to become in the future as a company. And naturally part of that is having the latest expertise, but also understanding what needs to happen to build things end to end across systems and also across organizations. Then as an example of let's say the breadth of what we're working on, that we don't really have a specific focus in mind. For example, while we have worked with autonomous vehicles, that's not the, let's say, the core focus, but rather just a selection of our portfolio of the work we've done, and we have really rather broad experience across all different kinds of AI applications that are actually needed and running in the wild. So more towards the original question that we had for the presentation today. We've over time more or less identified these three key practices that have really proven to be valuable when considering how to take AI into production. And I'll be going a bit more into detail in each of these separately, and then finish with a bit of examples from real customer work of how these practices actually were concretely realized in those different cases. So the first one here is trusted advisor. Is something that I already mentioned, that AI is rather new technology. It does touch a lot of different parts of an organization, and it's not enough just to pay attention to what happens in the technology itself and within an R&D unit, for example. The second bit is about saying that while there's a lot of fascination into building deep learning models, then nevertheless, the big challenge actually happens when you need to cost effectively put that running in production, and understanding what actually happens when there's surprises coming on the way. What is the impact to the customer? How much will it actually cost to fix things, and so on. So it's often always also a question that, what are you optimizing your R&D for? Is it for long-term results, or is it just for reaching something that is that you can achieve in short notice already? Then the third point is something that actually we really started as a hypothesis from the get-go, assuming that you can't really successfully bring AI into production unless you really have the latest expertise in that field. And that's something we've sort of been vindicated about over time, in a way that we've really seen that there's significant value in really having the latest expertise. It's not good enough that you knew what the latest AI was 2 years ago, because nowadays you can reach far better results, not only in terms of detection percentages and nice accuracy curves, but also in business results. So then stepping into the first one of these different practices, the first one was the trusted advisory. And the key, as I mentioned here, is that AI is really still an upcoming and weird technology. And that is really driving the need to have trust at the core of when you're building technology in that field. And that's based on a number of things. First of all, naturally, there's the breadth of the field. There's a lot of things happening, and there's a lot of rather optimistic promises of what the technology might achieve, at least at the level of demos. And that brings a lot of, let's say, gray area in between what is the current state of technology in many companies that are thinking of applying AI, and what they are reading about, what they're hearing about. And you have to build this sort of a bridge of trust and confidence that if you start on this journey, you will actually reach the other end of the bridge before the bridge is running out in the middle of the chasm there. The second point is that AI as such, and deep and where I'm saying AI, I'm generally meaning deep learning, since that's the way we usually see that silo AI, is that deep learning has a key strength with unstructured data, something that has been really hard for previous technologies to use, and something where giving the explanation to humans on what's actually happening is really hard. And this is bringing more of this kind of question marks in the middle. And then the third point here is perhaps sort of a reference to this ongoing joke of how do you improve deep learning applications, where in previous years, if you go 10 years back in time, and before the time of deep learning, there was actually started to be rather good, say, theoretical framework of how do you apply machine learning and how do you pursue better results methodically. And then with deep learning, we're still learning, like really, okay, why are things working? How could we make them better? When is it going to break? And we don't really have like well-defined, publicly acknowledged answers to all of those questions, and therefore there is a certain bit of trusting the process and seeing that, okay, it seems to work in practice, even if we don't really have the exact theory to back it up yet. And so combining all these, trust really comes before budget all throughout these different parts. The second bit is that AI is really complex and promising enough. It's touching a lot of different parts. Automation brought by AI, it's going to change operational models. Digitizing in general, that is sort of like accelerated by AI methods. It's changing the way business is done. And often deep learning is replacing, let's say, heuristic and other previous engineering efforts. All in all, AI is actually touching a lot of different bits and pieces of an organization. And you can't really successfully bring it on board and put into production unless you actually can draft out, describe, and bring through this change that is needed all across these different parts of the organization. So it's not just about having the trust of the engineers on the other side of the table, but it's much more broad, much more communal that needs to happen. Then on the other question of development versus operations, and here the first title is about data streams. Another question is, well, what's it about data streams? And the point is that actually, in comparison to previous, let's say, software and digital technologies, AI behavior is largely driven by whatever the data it has ingested during the life cycle, before and after taking that running in a real world case. And that means that when you are trying to understand why AI is behaving in a certain way, you actually have to understand all the details down to the data platform underneath. Where does the data come from? What is done to it? And what is done to the data source itself? And so as Petteri just mentioned, data is an attack vector nowadays. There's lots of identified ways you can attack AI methods through data. And auditing a model in general means auditing data. So it's never enough just to look at the model itself, but also understand, okay, what is the data you're going to ingest with the model throughout the operational life cycle. The second bit is more about this, let's say, maturity of AI, that we are still inventing new systems, model architectures, new processes, how to run and deploy AI, training the expertise that is needed to do all of this. And we're still not there. So we're not as mature as let's say the software field has grown during the past few decades. And that means that there's quite a bit of additional understanding you need to have about the operational picture. It's not just picking a handbook and following that at this point. Then about the deep expertise, the first point is really that, okay, if you assume that the technology is still developing really, really fast, then if you want to be really good at AI, it means that you have to be constantly getting better at it. So you can't just have really good expertise, but you have to also plan the ways how you will stay really good at AI as the technology changes. And the challenge there is also that the AI field is really diverging now into more and more approaches. It's not coming together, but it's really exploding in complexity. And it's rather unrealistic to expect a certain person to know everything about everything in AI nowadays. The second bit is maybe a continuation of this divergence question. That, for example, now a lot of different domains, a lot of different industries start to have their specific ways to build AI. For example, in genomics and pharma sector, there's a growing amount of model architectures, model designs, full AI research fields that don't really have a relation to how you could apply AI to any other field, for example, in that industrial sector, but it's fully specific on the genomic structure that you're focusing on. The second bit is about the data platforms that, for example, if you're picking a certain data platform, whether it's, let's say it's a cloud or it's an embedded system, the operational design, how you're going to run AI is totally different underneath. And you need to understand what are the specifics to consider when you're actually designing. Okay, this is the model I'm going to build, train, and deploy. And the third is then a bit of different kind of expertise that's now been really growing during the, let's say, a few past years, about growing, let's say, structured approach to how to consider ethics, regulations, human agency, and other related questions around AI. And that's actually speeding up the progress. Now we know how we should approach all of these different questions. So then after this, maybe looking a bit into the specific cases that chose as examples, and how these individual 3 practices were actually then present in these separate customer cases. So the first one over here is customer called Treat, and it was rather heavily in Finnish news, at least during the past year. So they've built and are building a next generation digital driven pharmacy platform called Apodigi. And we were there with them all the way from the get-go to design how to actually bring in intelligence to really improve the quality of care that pharmacies can provide to their customers. And this was really a deep conversation all the way from the get-go. Okay, how do we make this happen in the end? And that was then driving the rest of the work, where we worked really all across the system, building both the underlying intelligence, but also working on the user interfaces, both for pharmacy clients and also pharmacy employees. And the key point for this collaboration was really this sort of a agile loop, which is of course not that inventive. That's always been the case with digital development in general, but it has a bit of different flavor when it comes to AI, to really reflect not only what is the right way to build software and intelligence, but understanding what are the capabilities of the digital technologies, what can we bring to the users, and that will change the expectations, what we can provide to users. And then that will once again change, okay, what is the basis on which we could design the intelligence? So it does have additional components to what you can actually just expect when you're building a software product. Then a third point here with the deep expertise is more about this sort of seeing the expertise in a broader light. It's not just about models and algorithms. It can also be about how to reliably take those models into production. And that is sort of a key aspect of this work. But sometimes it also is about models. It's a balance in the end. What is reliable? What is simple enough? What is cost effective? What is good in terms of intelligence? And then it's a question, how do you choose? And when do you stop choosing? As a second case, there's been a very large heavy machinery manufacturer that we've worked rather extensively with now during the past years in multiple different projects, whether it's about intelligence for mine environments, vehicles, controls, machine control optimization, operator guidance, and a lot of different other things. And the key basis there is that there's a lot of different use cases. You have to understand what is the long-term roadmap. Which use cases are you going to build first? Where can you actually reuse investments and technology across different use cases, and also across a really large product portfolio where there's different types of sensors, available, different computing available, different use cases that need to be coming out of those models. So it's a really large portfolio of questions where you need to have a holistic understanding of how to approach that. And then this deep expertise is then naturally the key enabling part. You have to understand, okay, what are the implications of making certain choices? If I'm going to choose this, let's say, backbone architecture of a model and these head network architectures for an AI model, how can I expand that to all the different questions that are going to come up during the next year? And these sorts of questions were really central to this sort of long-term planning of this rather wide collaboration still ongoing. Third case is a bit of a down below ground once more, but in a different fashion. So sewage pipes, where our customer Tekniska Verken is a large Swedish public infrastructure company, and there we were building intelligence for automatic robots that are driving through sewage pipes and seeking problems to address, and then alerting the maintenance system and organization on those. So there, the advisory was really about understanding that the AI is going to be an integrated part of a full operational process workflow. And how do you tune the overall process, and how do you fit AI as a natural piece of that overall process? How does it fit in a human and AI interaction throughout the workflow? The second bit was about reliability and auditability, which were rather key points in this aspect as well, especially so that you could enable continuous improvement of the operations over time. You need to really understand why are certain decisions made. And then maybe jumping on to the last case that I had over here is with Kemira, which is a large Finnish industrial chemicals company, where we built chemical process and application optimization as part of an overall production process and its optimization. And here the key with broader collaboration with the customer was about really rethinking what is possible, what is the potential for this chemicals application process if we really be bringing new types of technology there. The other bit is how do we really quickly put it into production, where it's really production critical for those processes that are being managed in the factory, and designing how are we going to actually support and maintain it over the long period. And then, since there's a lot of industrial data available in this case as well, the question is really, okay, which data should we choose? How do we guide the design and search for the right models to really get to the right superior results over time? And here there was also quite a bit of iteration on constantly improving the results over time. So in summary, this key three practices were something that we have partly started our journey with when the company was originally founded, but some are also something that we've actually just learned on the way here, and seeing that, okay, this is something that we can really apply across different problems that we are tackling. So in addition to having trust-based overall broad advisory of the customer, understanding what will happen when this thing actually goes into production, and then basing it all into understanding the latest in AI technologies. So those were the basis for the first 100+ in production AI projects that we've built. So now it's been time to go to the next 100+ next. But that's all I had in mind for today. So as things naturally go, we are growing pretty fast and also actively looking for new AI expertise. So really happy to hear for interest in those as well. Thanks.